What if the stars you see in the night sky aren't actually physical, solid objects, but just localized pixels rendering on a cosmic screen?
I know, it sounds like science fiction, right?
Totally. But today, we're looking at a massive stack of cutting-edge theoretical physics papers that suggest the universe isn't a container of matter at all. It's a giant, infinite hard drive.
Yeah, and it might actually be running out of storage space.
Exactly. So for you, the listener, today's mission is to take these, frankly, highly complex theories from relational quantum mechanics to black hole thermodynamics and conformal cyclic cosmology and, extract a unified mind-bending narrative about the ultimate fate of the universe.
Right, and doing that requires a complete departure from how we intuitively perceive reality. I mean, we're so used to visualizing the cosmos as this vast theater.
Yeah, like you have the stage of space-time.
Exactly, you have the stage and you have the actors like the planets, the stars, the particles, and they're just moving around on it. But to really understand the end game of the universe, we have to look past the actors entirely. We have to examine the stage's underlying code.
Okay, let's unpack this. Because before we can understand how the universe ends, we kind of have to redefine what it's actually made of right now.
We do.
And that means diving straight into the deep end with Carlo Rovelli's relational quantum mechanics, or RQM for short.
Yeah, RQM is fascinating.
And since we're assuming you, the listener, are already familiar with the basics of like the wave function and quantum superposition, we aren't going to rehash the double slit experiment today. We want to look at Rovelli's radical reinterpretation of the math itself.
Right, because under the standard framework, people often treat the wave function as a literal physical object, propagating through space.
Like an actual wave of water or something.
Exactly, but RQM strips that physical illusion away entirely. In an information-centric framework, the wave function is purely a mathematical probability space of potential interactions.
Right.
Rovelli argues that reality is entirely relational. Between interactions, physical systems do not possess absolute values.
Wait, hold on. So if I have a particle sealed in a perfectly isolated vacuum chamber, you're saying it literally lacks physical properties?
Yes. A particle doesn't have a defined position or momentum or spin when it's completely isolated.
It's like floating math.
Yeah. Floating math is actually a great way to visualize it. It doesn't have properties because, well, properties aren't inherent to the object itself.
Okay.
Properties are the result of an interaction. And this completely reframes the whole concept of a measurement in quantum mechanics.
Right, because we always get bogged down in this weird anthropocentric idea that a measurement requires a conscious observer, right? Like a scientist with a lab coat looking at a dial.
Exactly, which is a big misconception. In RQM, an observer is any interacting physical system.
Any system.
Any system. A stray photon bouncing off an atom, that is an observation. When two systems interact, they are simply resolving their own lack of information about each other.
Oh, wow. So it's literally an information update, like a database syncing.
That's a perfect analogy. And that sync is what we perceive as reality.
That's wild.
What's really fascinating here is how this instantly clears up the long-standing debate over quantum entanglement.
Oh, right. Einstein's nightmare.
Exactly. We know the math of entanglement implies that measuring one particle instantly updates the state of its partner, regardless of the distance. And yeah, Einstein hated this. He famously called it spooky action at a distance.
Because nothing can travel faster than light.
Right. But under RQM, the spookiness vanishes. If reality is fundamentally just information, entanglement is simply a statistical correlation of observer-accessible data.
Okay, wait, let me make sure I'm getting this. When you measure your particle, your knowledge of the whole system updates instantly.
Yes.
There is no physical thing or signal traveling between the particles across the galaxy.
None. The universe just updated the ledger.
Man, when I was reading these papers, the analogy that kept screaming out to me was a video game engine.
Oh, I like that. How so?
Think about playing like a massive open world game. The game engine doesn't actively process and render the physics of every single leaf in a forest 50 miles away from your character.
Right, because that would completely fry the processor.
Exactly. Those unobserved parts remain as raw code. Pure potential. The macroscopic world you experience only renders its definite, stable properties because of the sheer volume and high frequency of continuous interactions happening right in front of you.
That's spot on. And the scientific term for that rendering is decoherence. It fits your video game analogy perfectly.
Okay.
The macroscopic reality you experience every day, the chair you're sitting on, the device you're using to listen to this deep dive right now, it's just a localized region of incredibly dense information resolution.
Because the particles are bumping into each other so much.
Exactly. The interactions are happening so fast, trillions of times a second, that the system just appears solid and classical to us.
Okay, so if the universe is fundamentally built on information and interactions, there has to be like a physical limit to how much data can fit in one place, right? Before the universe's hard drive crashes.
Yes, there is. And that brings us right to black holes.
The ultimate crash.
Exactly. More specifically, it brings us to the Bekenstein bound. Physicist Jacob Bekenstein mathematically proved that there is a strict, absolute limit to the amount of information that can be contained within a given region of space.
Right, but the formula he came up with, I mean, it breaks my brain a little bit.
It's definitely counterintuitive.
Because Bekenstein realized that the maximum amount of information isn't proportional to a region's three-dimensional volume. It's proportional to its two-dimensional surface area.
Right.
Hold on. That defies basic geometry.
Yeah.
If I have a cardboard box, I measure how many books fit inside by calculating the internal volume, not by measuring the surface area of the cardboard wrapping.
In our everyday macroscopic world, yes, of course, volume dictates capacity, but at the extreme quantum limit, gravity completely warps that logic.
Okay, so how should we think about it?
Think of the event horizon of a black hole not as, like, wrapping paper around a 3D sphere. Think of it as a densely pixelated 2D screen.
Oh, where?
This is the birth of the holographic principle. It suggests that the three-dimensional volume of a black hole is actually a mathematical illusion.
An illusion.
Yeah, a black hole is the densest possible packing of information allowed by the laws of physics. It holds exactly one quantum bit, one qubit of information per Planck area on its event horizon.
Okay, here's where it gets really interesting for me.
Yeah.
Because when I was digging through these papers on the holographic principle, it suddenly hit me, this is exactly how enterprise IT systems work.
Really? How so?
Black holes are basically running a content addressable storage system, or CAS. It's a data deduplication algorithm.
Okay, unpack that IT analogy a bit more, because
Yeah.
it actually beautifully illustrates the no-hair theorem of general relativity.
Yeah, so in a massive corporate computer network, you might have, say, 1,000 employees who all download the exact same 10 megabyte PDF file.
Which takes up a ton of server space.
Right. But a CAS system doesn't save 1,000 copies of that file. It saves one single copy, deletes the other 999, and replaces them with a tiny hash pointer.
A pointer.
Yeah, just a little string of code that basically says, hey, look over here. It massively reduces the storage footprint. So when a giant star collapses into a black hole, it carries a vast amount of highly specific, redundant structural information.
Oh, I see where you're going. Trillions of identical carbon atoms, complex chemical bonds, unique thermal signatures.
Exactly. And according to the no-hair theorem, once that collapsing star crosses the event horizon,
All of that distinct redundant complexity is completely stripped away.
yes,
The black hole only retains and displays three basic macroscopic parameters to the outside universe: total mass, electric charge, and angular momentum.
it deduplicates the star.
It really does.
The event horizon breaks down that incredibly redundant atomic structure, encodes only the raw, fundamental quantum bits onto its 2D surface, and just throws away the fluff. The universe is literally optimizing its storage. Black holes are the ultimate data compressors.
They're enforcing maximum informational efficiency. However, this incredible compression mechanism introduces what is arguably the most fiercely debated conflict in modern physics.
Oh, the black hole information paradox.
Exact.
Because black holes are perfect zip files. But then Stephen Hawking threw a massive wrench in the gears when he proved they actually evaporate.
Yes, Hawking radiation.
Since we know Hawking radiation causes black holes to slowly leak mass and eventually explode, we hit a brick wall.
A huge brick wall. Specifically, we hit the wall between quantum unitarity and thermal evaporation.
Okay, break that down for us.
So, unitarity is a foundational pillar of quantum mechanics. It states that information cannot be permanently destroyed. The past must always be determinable from the present.
Right, you can always rewind the tape.
Exactly. But Hawking's original calculations showed that the radiation leaking out of a black hole is perfectly thermal. It is totally random, featureless noise.
Meaning, if I throw a detailed encyclopedia made of matter into a black hole,
Yeah.
And then I throw an identical encyclopedia made of antimatter into another identical black hole. They both emit the exact same random featureless radiation.
Yep. The unique quantum information that made them different is gone.
If the zip file deletes itself with a random overwrite, the data is permanently destroyed.
Which completely breaks quantum mechanics. And for decades, physics was just stuck here.
But there's a new resolution, right?
Yes. Recent mathematical breakthroughs regarding the Page curve and entanglement islands provide a stunning resolution to this. We used to think the radiation was totally disconnected from the interior of the black hole.
But it's not.
No. Tracking the entanglement entropy of the radiation over time changes the picture entirely.
How exactly? Because saying the information just escapes sounds simple, but the mechanism in the papers is wild.
It is wild. The mechanism relies on semi-classical gravity breaking down at a specific point in the evaporation process, known as the Page time.
The page time. Okay.
Early on, the Hawking radiation does look like random thermal noise, and the entanglement entropy between the black hole and the outside universe steadily rises. But at the Page time, the math shows the emergence of replica wormhole geometries.
Wormholes inside the black hole.
Essentially, yes.
Mhm.
Without getting buried in the tensor calculus, the geometry of spacetime inside the black hole mathematically bridges to the exterior radiation. An island of information inside the black hole becomes fundamentally entangled with the radiation far outside of it.
Oh, wow.
So the late-stage radiation complexly encodes the initial state of everything that ever fell in. The information essentially bypasses the event horizon entirely.
That is incredible. And if we pull back from the wormhole geometry for a second and look at this through the lens of relational quantum mechanics, it completely changes how we view the loss of information, doesn't it?
It really does.
Let's go back to my example. Let's say I throw my highly detailed encyclopedia into the black hole. Does the universe actually forget the words? Or am I just locally locked out of the library until the Hawking radiation finally updates my information?
If we connect this to the bigger picture of RQM, it provides a profound ontological resolution. You are just locally locked out.
I knew it.
Information isn't some physical ledger in the sky that gets objectively erased. Information only exists relative to a system capable of interacting with it.
Right.
For an observer falling into the black hole alongside the encyclopedia, the information remains perfectly defined. There is no paradox for them. But for you, hovering safely outside, your interaction pathways with that book have been severed.
Ah, so the universe doesn't lose the data. It just dynamically renegotiates who has access to it.
Exactly. The Hawking radiation is just the mechanism by which the universe continuously re-resolves and updates those informational boundary constraints over trillions of years.
Trillions of years.
Right.
Right, so let's talk about those trillions of years. Let's take that evaporation process, that agonizingly slow leaking of deduplicated information back into the void, and let's fast forward the cosmic clock to its ultimate extreme.
We should. The timeline of cosmology is staggering, and it really helps to understand where we are right now.
Okay, where are we now?
We are currently in the stelliferous era. We have an abundance of stars, active galaxies, and nuclear fusion. Because of all this activity, the rate of particle interaction is incredibly high.
And as we established with RQM, a high interaction rate means a very stable, highly rendered classical reality.
Exactly.
But the fuel eventually runs out, the stars burn out. We transition into the degenerate era, which is dominated by dead, glowing remnants, like white dwarfs and neutron stars.
Yeah, the universe cools down significantly.
The frame rate of reality begins to drop, essentially, because the sheer volume of interactions plummets.
That's a great way to phrase it. And
Uh-huh.
following that, by 10 to the power of 40 years from now, we reach the black hole era.
10 to the 40. That's ungraspable.
It is. If protons decay, which many unified field theories predict, all normal atomic matter will simply dissolve into radiation.
So no more stars, no more planets.
None. The only macroscopic structures left in the entire cosmos will be black holes. For an incomprehensibly long time, the only meaningful physical process happening in the universe will be the slow emission of Hawking radiation as these black holes just bleed out into the dark.
And when the final supermassive black hole completes its final evaporation,
Yeah.
we cross an ultimate threshold. Sometime beyond 10 to the power of 100 years, we enter the dark era.
Heat death.
Yes, heat death. In the dark era, the universe is just an incredibly dilute gas of massless photons and gravitons.
It's radiation.
It's radiation. And because dark energy is constantly accelerating the expansion of space, these surviving particles are stretched infinitely far apart from one another. Their interaction cross-sections basically approach zero.
Meaning they effectively never bump into each other again.
Never again. So what does this all mean? I mean, if time and classical reality are defined relationally by interactions, what happens when interactions drop to zero?
Without interactions to resolve states, the macroscopic reality fades away entirely. The universe effectively becomes a single, unmeasured quantum system locked in an eternal superposition.
That is haunting.
But it goes even deeper than that. Because the universe is dominated entirely by massless photons moving at the speed of light, the physical mechanism of time experiences a fatal breakdown.
Wait, time breaks down.
Yes. According to relativity, massless particles do not experience proper time. From a photon's perspective, the moment it is emitted and the moment it is absorbed are the exact same instant.
Oh, wow. This means the time you experience, like the seconds ticking by on your watch right now, isn't some absolute property of the universe.
Yeah, it's not.
It's just the lag time between your body's particles interacting with the room around you.
Exactly. Without any physical mass to act as a clock or particle interactions to tick the seconds, trillions of years pass in effectively zero relational time.
So the long times of absence between universes, this terrifying idea of waiting trillions of quadrillions of years in the freezing dark, that's an illusion.
It is. The disappearance of time is mathematically literal. If there is no clock to measure the interval does not physically exist.
But, I mean, if time stops and scale completely loses its meaning,
Right.
is that the final end?
Well, not if you ask physicist Sir Roger Penrose.
Right.
He argues that that exact state of absolute freezing nothingness is actually the mathematically perfect setup for a new Big Bang.
Okay, so this brings us to conformal cyclic cosmology, or CCC.
Yes, CCC. Penrose rejects the standard inflationary model that says the Big Bang was the singular, absolute beginning of everything. Instead, he proposes the universe iterates through infinite cycles, which he calls eons.
Eons. So our universe is just one eon in an endless chain.
Precisely.
And the linchpin of his theory is conformal rescaling. Let's break down the geometry of how this actually works, because if you have no mass in the universe, you have no physical rulers, right?
Right.
You literally can't measure distance.
Exactly. Mass dictates the scale of the universe. Without it, the infinitely large, expanding, freezing cold, dark era mathematically loses its sense of physical scale entirely.
Okay.
In conformal geometry, you can transform the scale of a space without changing the angles of the structure. Because the dark era has no mass to define its size, its geometry can be conformally squashed down into a state that is mathematically indistinguishable from the infinitely small, blistering, hot singularity of the Big Bang.
That is so hard to picture, but so cool.
Yeah.
Extreme cold, empty infinity becomes mathematically identical to an infinitesimally small point.
Yes.
It's like zooming into a fractal. You zoom into the cold, empty darkness forever and ever until suddenly the sheer lack of physical scale causes the mathematical image to loop back on itself. And the zoomed-in picture looks exactly like the fiery Big Bang we started with.
That's a beautiful way to visualize it, but we should note, this creates a massive debate over entropy.
Right, the entropy reset.
This raises an important question, and it is easily the most highly criticized aspect of CCC. For the universe to cycle infinitely without violating the second law of thermodynamics, the universe's total entropy has to drop back down to near zero at the start of every new eon.
Basically, the universe has to clean up its mess.
Precisely. And Penrose argues that the only mechanism powerful enough to do this is black hole evaporation.
Ah.
But here's the massive divergence from the page curve theory we discussed earlier. For CCC's entropy reset to work, Penrose claims black holes must permanently destroy information.
Oh, they must violate unitarity.
They have to. The entropy swallowed by black holes must be erased from the universe forever when they evaporate, effectively sanitizing the cosmos for the next eon.
Wow. So we are forced to choose. Is quantum information truly preserved forever, or must it be sacrificed on the altar of thermodynamics to birth a new universe? It's a staggering conflict.
It really is. Penrose even searches for empirical evidence of this.
Right, the Hawking points.
Yes. He points to phenomena he calls Hawking points. These are theorized to be the imprints or scars left behind by the supermassive black holes of the previous eon evaporating.
And he claims they show up as distinct circular hotspots in our current cosmic microwave background radiation, right?
Yes.
Literally seeing the ghosts of dead universes in our sky.
It is a profound concept, though we must impartially note that the broader cosmological community remains highly skeptical of this.
Yeah, we have to be clear about that.
Most independent analyses of the cosmic microwave background attribute these hotspots to standard lambda-CDM Gaussian anomalies.
Which is to say, just normal, expected random fluctuations in the radiation, not definitive proof of a previous universe bleeding into ours. We are taking sides here, just reporting what the papers say.
Exactly. The debate is ongoing.
Still, the theoretical journey is just incredible. Let's synthesize this massive arc we've just been on.
Let's do it.
We started by realizing that reality isn't made of solid stuff. It is a recursive informational loop. Matter only takes form and renders classical reality when it interacts.
Right. And black holes are the cosmic hard drives that compress and deduplicate this information, pushing it to its absolute physical limits on a 2D surface.
And when those black holes finally evaporate into the dark era, the interaction space of the universe drops to absolute zero. The cosmic canvas is wiped entirely clean.
Yes. Without mass to measure it, the universe forgets its own geometry, losing all sense of time and scale, allowing the conformal boundary to squash down and the cycle of existence to begin anew.
It really changes how you should feel when you walk outside and look up at the night sky. The next time you are out looking at the stars, remember that they aren't just burning balls of gas sitting inside a dark box. They are localized, incredibly dense pockets of information processing.
They really are. They are the very interactions keeping the time of the universe ticking.
They are the rendering engine of our current eon.
Beautifully said.
Which leaves us with a final provocative thought to ponder. If time, space, and classical reality only exist when there's a high density of interactions, does that mean the universe fundamentally requires complex systems, perhaps even life itself, to act as the very machinery that keeps its timeline running?
It's a huge question. It suggests we aren't just passive observers sitting in a container, we are the processors.
Are you not just living inside the universe, but actively participating in the rendering of its reality? It turns out that theoretical X-ray machine we use to look at the fabric of reality, it isn't broken. We just didn't realize we were looking at the raw code instead of the final picture.